Welcome to my lesson on learning hierarchy analysis. Imagine that you're on a long bus ride with a friend who doesn't speak English very well. You feel your stomach rumbling. After an hour or two, you arrive at your destination and eat a delicious meal. After the meal, you turn to your friend with a smile and say, "If I'd eaten before we got on the bus, I wouldn't have been so hungry." Your friend, the one who doesn't speak much English, turns to you and says, "Eh?" They clearly have no idea what you mean. If you're not an English language teacher, or someone who has mastered English as an additional language, you might have a tough time explaining the structure of this sentence to your friend. But if your friend insisted on understanding the sentence, and you really wanted them to get it, a learning hierarchy analysis would be an appropriate method. Once you've completed this video lesson, you'll have a pretty good idea of what learning hierarchy analysis is and how and when to apply it. You'll be able to define what it is and state its underlying assumptions, understand how to conduct a learning hierarchy analysis, select contexts for using a hierarchy analysis, talk about its advantages and disadvantages as a task analysis method, and decide how valuable the method might be for a specific learning outcome of your own. According to Jonasson and colleagues, the concept of learning hierarchy was developed by Robert Gagne to depict how a set of intellectual skills are related. As in the case of the third conditional in English, learning hierarchies often consist of a set of rules. Gagne argues that many intellectual skills can be represented in a learning hierarchy, including rules of English grammar and punctuation, mathematical and scientific rules and concepts, and even skills in the social sciences, such as comparing and contrasting governmental systems and predicting social trends. Drawing on research of both behaviorists and developmental psychologists, Gagne's basic assumption is that the mastery of an intellectual skill involves the mastery of prerequisite skills, or that learning is cumulative in nature. It is also assumed that through analysis, it is possible to create a hierarchy of skills that moves from simple to increasingly more complex skills, culminating in a target learning outcome. Jonasson and colleagues explain how to conduct a learning hierarchy analysis. First, you familiarize yourself with the topic so that you can state the terminal learning outcome. Next, it's necessary to identify the capabilities a learner needs to achieve the outcome and identify levels of prerequisite skills, from more complex to simple. At some point, you have to decide what the entry-level capabilities are to avoid unnecessary levels of simplicity. For example, in the example of the third conditional, it is assumed that learners already have a certain level of knowledge of English grammar and that it is unnecessary to describe more basic grammatical knowledge. The implication of the learning hierarchy is that the target skill can be taught from the bottom up, from more basic to more sophisticated skills. Once you have determined the learning outcome and all the necessary prerequisite skills, you can construct the learning hierarchy and verify it, either through logical analysis or an empirical validation with a sample of learners, if possible. As Jonasson and colleagues state, learning hierarchy analysis has been used in a variety of contexts to describe the prerequisites for learning outcomes. The tool can be used to plan a single lesson, but also to develop an entire curriculum in which learning builds from simpler to more complex intellectual skills. It can also be used for technical training in which performance involves problem solving and decision making. In addition, The technique can be used in tandem with other analytical techniques to describe the steps in a procedure or information processing. Earlier, I used an example of teaching the third conditional in English. Instruction on the third conditional based on a learning hierarchy analysis might take a single lesson, followed by extensive, meaningful practice. The example I'll provide now is a curriculum map for a unit in English for Academic Purposes, or EAP unit, requiring several lessons, possibly taking place over a few weeks. At the top is the target learning outcome, writing an academic summary response essay. Next comes learning objectives that are entry capabilities needed to write an academic summary response essay. The first level prerequisites to those entry capabilities are listed beneath the entering capabilities. For example, in order to be able to respond to an academic text, the learners must know how to make claims about an author's ideas. The first level prerequisites are followed by second level prerequisites. In order to make claims, learners need to be capable of expressing agreement and disagreement effectively, assessing the quality of evidence provided in the text, connecting ideas to personal experience, and synthesizing information provided in multiple texts. I have placed these prerequisite skills below the dotted line because the learners may have been introduced to these objectives in prior units or courses and may already have prerequisite knowledge or skills in meeting these objectives. However, research in second language acquisition suggests that knowledge and skills need to be practiced routinely and in specific contexts for students to improve their mastery of a language, so these second level prerequisites are included. It is possible to go down to third level prerequisites. Although it is assumed that learners have already acquired these concepts, information, or strategies, it may be necessary to remind some students of these prerequisites and in some cases create opportunities for practicing them. This example of a learning hierarchy analysis and the one presented earlier can be used to discuss some of the advantages and disadvantages of a learning hierarchy analysis. Learning hierarchy analysis has advantages and disadvantages. Let's start with advantages. Perhaps the greatest advantage is that it allows instructional designers to systematically determine the entry-level learning objectives and prerequisites involved in the achievement of a learning outcome. For instructors, a learning hierarchy analysis may reveal prerequisites which they hadn't taken into account in their teaching. For example, in the case of the third conditional, if the instructor is a native speaker of English, they may have implicit knowledge of how to form the third conditional, but not know the prerequisite rules involved in forming standard and inverted forms of the third conditional. A learning hierarchy analysis makes the rules explicit to the instructor and helps them to teach the grammar point in the right order. Another advantage is that learning hierarchy analysis has been validated across various subject areas and types of programming. In other words, it has proven usefulness as a task analysis method. The two examples I have provided show that learning hierarchy analysis is useful for teaching a single lesson, how to form the third conditional, and much more complex instructional units, as in the second example of writing a summary response essay. Finally, Jonassen and colleagues point out that learning hierarchy analysis can be used with other forms of analyses, such as procedural or information processing. Now, let's look at some disadvantages. First of all, creating a learning hierarchy analysis involves some subject matter expertise, not only to decide what learning outcomes are important, but also to determine the prerequisites and their sequence. The examples I have chosen, the third conditional and writing a summary response essay, are learning outcomes that I am familiar with as an English language instructor. It would be more challenging for an instructional designer without explicit knowledge of the grammatical system in English or an explicit understanding of the strategies good readers use to interpret and summarize a text to complete a learning hierarchy analysis in the field. Second, the underlying assumption of learning hierarchy analysis is that learning is incremental or cumulative in nature. However, certain skills may not lend themselves to a learning hierarchy analysis. For example, some learning theorists suggest that metacognitive skills, those skills that are involved in planning, monitoring, and evaluating one's own learning, are types of learning that cannot be taught sequentially. There is also evidence that language skills, such as learning the third conditional, are not learned sequentially either. First, language acquisition is a highly social activity, learned mainly through imitation and incidental learning. Even in my second language, which I learned through immersion, there are features of the language which I can use but can't explain how I learned them. Therefore, it is possible that learning hierarchy analysis is more prescriptive than descriptive, which leads to the final point. For many learning outcomes, it is possible to sequence instruction in multiple valid ways. For example, writing an academic summary response essay can be and is taught in ways that differ from the learning hierarchy analysis presented here. Therefore, learning hierarchy analyses require validation through logical analysis and empirical study, and may be highly dependent on the context in which they are applied. So, is learning hierarchy analysis the right tool for you? If your learning outcome involves discriminating between one thing and another, a concept, a rule, or solving a problem, then the answer may be yes. But if the outcome is highly technical or, conversely, difficult to break down into prerequisites, another job analysis technique might be more appropriate. If you believe that learning is cumulative in nature and that intellectual skills can be mastered through sequential steps that move from less to more complex, then learning hierarchy analysis might be the way to go. However, if you question the assumption that learning is cumulative, or that some types of knowing do not involve a step-by-step process from simple to more complex, then you may hesitate to use this tool. Finally, if you have expertise in the content that is the object of the learning hierarchy analysis, or if you have the ability to work closely with a subject matter expert, then learning hierarchy analysis can work for you. If you don't have expertise or the ability to work with a subject matter expert, then it will be very difficult to use learning hierarchy analysis as a tool. I hope that this video has provided you with a useful introduction to learning hierarchy analysis, and that you have the confidence to use it in your own instructional design work.